So let's now go ahead and try to finish off the rest of example 1. We ended the last video by saying that we could try to test the two hypotheses that we had formed up here, and we were going to test hypothesis 1 specifically by ultimately trying to flip a coin. So let's see how this would work. Now if we were in a classroom together, I would actually bring in some coins and we would attempt to flip them together to try to simulate this idea. But instead, I'm going to show you how we can do this in a simulation applet that is actually going to be in our Blackboard shell. So I'm going to go ahead, I'm going to move over to our Blackboard shell, which is right here. And down on the side, you'll see that I have a simulation applet. I'm going to click on that applet and encourage you to do the same. Up here at the top, I have a link for one proportion, all the way at the top left, and I'm going to click on that as well. Now, what I have here is a little applet that will allow me to actually simulate the idea of flipping a coin. Let's take a look at this. Notice that I have 3 different values up here. I need to know what's the probability that I would flip a coin landing on heads. Well, let's pretend right now that heads maybe stands for something like getting the color of red. Okay, since we got 15 out of 16 chips being red, let's say that every time we flip this coin and it lands on heads, that will kind of be like the machine coloring a chip the color red. Okay, it's got a 50-50 shot. And so, just like the machine has a 50-50 shot of coloring a chip red. Now, I can go here and I can say the number of tosses. Well, I can see here that I maybe want to do 16 tosses because just like the machine, I want to color 16 different chips. And so I'm going to do that with a coin flip here. Now if you take a look, you can see that when I click this Draw Sample button, it's going to actually simulate flipping a bunch of coins and separating them out into heads and tails. Remember that we said if I ever get a heads, that's going to be like coloring a chip red, and if I get tails, that's like coloring a chip blue. So in this case, you can see that I colored 9 red chips and 7 blue chips. Okay, so how many again did we get when we pulled our handful of chips out of the bin? Well, we got 15 red and only 1 blue. Okay, so we didn't kind of repeat that here. But notice that down here in this little picture, I have a little number line. It's counting the number of heads, or the number of red chips. And you can see right now there's a little dot on there. That little dot stands for 9, the 9 heads that I just got. So this will kind of help keep track of all the different things that we have. Notice I could hit Draw Samples again. And what it would do is it would flip the coins 16 times, so like coloring chips red and blue. And this time, let's see, I end up with 10 heads and 6 tails, and I can put that on the number line. Now, if I uncheck this animation box, it won't go through the flipping of the coin visually, but it will at least show me the final result. Notice here, after I clicked, I got 9 heads and 7 tails. I'll do it again. Oh, 9 heads and 7 tails again. Now 8 and 8. Now 8 and 8 again. And you can notice that every time I click this button, I'm getting a new result. Oh, wow, look at this one. 13 heads and only 3 tails. So I can go ahead and I can click this a lot. Now, notice here, this tracks for me how many total times I've clicked it. Let's just do like 30 times, like this was maybe a full class of students. Okay? Now, when I take a look at this picture, I can start to see some patterns maybe beginning to emerge. So out of the, say, 30 times that I've done this, how easy has it been to get something like 15 heads or 15 red chips? Has it even ever happened? It doesn't look like it. Notice that down here, though, I can actually ask the simulation applet here to count up the number of heads that have been flipped. And we want to have something that's as extreme as 15. That's kind of what we're interested in counting. Notice if I click that and then the count, it's going to draw a line where the 15 is, so I can see like how many dots are on the line or past it. And so far it says we've had 0 15s out of 30 tries. Now maybe I could keep going here, right? Like I can keep adding dots to the picture just by continually spamming this over here. You know, maybe I'll go all the way up to like 100, right? I can imagine doing this 100 times. And I can say, how easy was it to ultimately get 15? Well, has it happened yet? No. So far it's seeming like it's pretty hard, right? Like it's not easy to get 15 out of 16 just by luck. Okay, well, again, this is only happening 100 times. Notice I don't here, though, have to just click this button over and over. That's what this category is for, number of repetitions. And our general rule of thumb as this class is that when we run one of these simulations, we're oftentimes going to want to go ahead and run this many, many, many times. We want to repeat the experiment that we're doing here over and over and over again, usually up into the thousands of times. So here I'm actually going to go ahead and input 1,000. This is going to do the flipping of the coins and plotting of a dot 1,000 more times. So this will jump up to 1,100. There it is. Now, if you take a look here, you'll see that there are so many dots in the picture that they all get so scrunched together, they're starting to look like solid lines, right? So I can see here then that over on the side, this is counting for me how many times I've gotten 15. Okay, so is it possible to get 15 out of 16? Well, yeah, definitely. But notice it's only happened 2 times out of 1,100 times. As a percentage, notice that that's not even 1%, right? That's like 0.18%. That's super low. Well, this should tell us something. This should tell us exactly how we should feel about hypothesis 1. We were just testing how easy it was to get lucky. Well, let's see what we have here. I'm going to go ahead and say that for our class simulation, we can say that out of 1,100 attempts of selecting 16 chips, we saw that we were able to get 15 red chips, that's out of 16, right? 15 red chips out of 16, only 2 times. That was it. So we saw that this is roughly equivalent to 0.18%, right? Like a very low percentage. And so what we're seeing here is some evidence that can help us determine how well do we think that getting lucky is a good explanation, right? How good of a fit is saying, we just got lucky. Is it easy to get this lucky? No. I mean, it doesn't look like just getting this just by chance is very easy to do. So notice down here on part E, I'm just going to go ahead and record the simulation stuff that we did in Blackboard. So notice we said that our probability of success, that was the chances of getting a red chip, that was 50%. Because the machine produced half red chips and half blue chips. Sample size, we did 16 because we wanted to simulate picking 16 chips out of the bin. And the number of samples that we ultimately used was 1,100. Really, anything above 1,000 is going to be good. And now I should be able to reach a conclusion. I'm almost going to copy a lot of what we did up above right down here. So I can state that by the simulation, we see that getting 15 red chips, this is again out of 16, by just luck happens only about 0.18% of the time, right? We're kind of explaining first what the simulation told us. This is kind of almost like part 1 of our explanation for our conclusion. Part 2 would be kind of then saying, well, again, if luck is a good explanation for this at a very slim percentage, then does hypothesis 1 really fit? I would go with no. So in this case, I would say that we choose to believe hypothesis 2. But I'm going to write down what hypothesis 2 says in words. So I'll say that we will choose to believe hypothesis 2. which states that the machine is making more red chips than blue chips. That seems to be the best explanation of what's going on. Now notice that there's some very important key wording here in that I state we will choose to believe. Notice I didn't say hypothesis 2 is correct, because I don't know that. But what I do know is that it seems very unlikely that hypothesis 1 is correct. Hypothesis 1 doesn't seem like a good fit. And so I choose to go with hypothesis number 2. This is the basic way that we would always write conclusions when doing one of these simulation questions. And in fact, I have a whole set of worksheet problems related to section 1, or chapter 1. And those worksheets, one of them is a simulation worksheet where you can go ahead and try to practice working through these simulations on your own. In fact, on exam 1, you will definitely be asked a simulation question where I'm going to ask you to go ahead and try to interpret the results of a simulation. Now, the last thing that I'll say here is related to this percentage, which I'll underline here in red. One of the important things that we have to establish is kind of a general cutoff for what percentage would be acceptable and what percentage would be unacceptable for kind of sticking with or going with hypothesis number 1. So I'm going to go ahead and just kind of put in an extra little note right over here on the side. So I'll state that we will always think that hypothesis 1 is not a good fit if this percentage is less than 5%. 5% in this class is going to be a pretty standard cutoff for us. If this percentage here comes out under 5%, then we're going to say that is this thing happening by luck? Probably not a good call. But if this came out here as, say, 18%, then we would have said, hey, you know, luck seems like a pretty decent explanation. Let's go with that. Things can happen about 18% of the time. Yeah, not bad. But if I get under 5%, I'm always going to choose to ditch hypothesis 1 and go with instead believing hypothesis 2. So this concludes for us our first simulation, and we'll see in some of the other sections that we'll do some more simulations. But this is one of our most complicated ideas in all of stats because it is the idea of stats. And what we're going to do in the videos to come in this section and in later chapters is to try to build upon what we've established here, to build upon this process and to kind of add some terminology and some additional structure to what we've covered here.